So I'd like us to look at measurements of variation or measure of dispersion. And when we talk about the measures of variation, we talk about help us in studying the important characteristics of distribution. So the measures of dispersion, they are useful in statistical work because they indicate whether the rest of the data are scattered around the mean or away from the mean. So if the data is approximately dispersed around the mean, then the measure obtained is small. If it is away from the mean, then the measure will be a big number. Then let's look at the significance of measuring variation. Significance of measuring variation or dispersion. Number one, to determine the reliability of an average. So we do it to determine the reliability of an average. Is that average that we got reliable? Okay. We will know if it is reliable by calculating a measure of dispersion so that you can see whether it is around the mean or away, so that you can know whether you can rely on that mean. Number two, to serve as a basis for the control of variability. To serve as a basis for the control of the variability. That is to compare two or more series with regard to their variability. And four, to facilitate the use of other statistical measures. Yeah, this one will also help us to use other measures. It will be facilitating us to use other measures of dispersion or other measures that are there in statistics. Then, property of a good measure of dispersion or variation. Number one, it should be simple to understand. Should be simple to understand. Two, should be easy to compute. Should be easy to compute. It should be rigidly defined. Four, should be based on every observation of the distribution. Should be capable to further algebraic treatment. Number six, it should have sampling stability. And number seven, it should not be unduly affected by extreme observation. Methods of studying variation. Number one, the range. Okay. We have the mean deviation. We also have the interquartile range. This one is also called quartile deviation. Then the standard deviation. And lastly we have the Lorenz curve. Let's start with the range. The range is defined as the difference between the highest and the smallest values in a frequency distribution. This measure is not very efficient because it utilizes only two values in a given frequency distribution. We also need to observe that the smaller the value of the range, the less dispersed the observation are from the arithmetic mean, and vice versa. So another point, the range is not commonly used in business management because two sets of data may yield the same range. but end up having different interpretations regarding the degree of dispersion. Another point, range is the simplest method of studying variation. So when it comes to range, range is equals to largest value minus smallest value. R is equals to L minus S. Then coefficient of range is equals to L minus S over L plus S. Illustration. The following are prices of shares of a company from Monday to Saturday. Required. Calculate the range and coefficient of range. So we have said that R is equals to L minus S. So in this case, which is L? 250. And S? 160. It's equals to 90. What about coefficient of range? It is L minus S over L plus S, which is 90 over 10. Get what? 0.219. Put like that. Merits of range. 1. It is the simplest to understand and easiest to compute. Number 2, it takes the minimum time to calculate the value of range. Limitations. Range is not based on each and every observation of the distribution. 2, it is subject to fluctuation from sample to sample. 3, range cannot be computed in case of open-end distribution. And lastly, range cannot tell us anything about the character of the distribution. Uses of range. 1, quality control. 2, fluctuations in the share prices. And 3, weather forecast. So for the quality control, we keep check on the quality of the product without 100% inspection. Just take the lowest one here. Kama inatupia range kubwa, unajua si nzuri. Okay. For fluctuation, the prices of shares ni vitu tunafanya. These are the share prices for a week. Okay. We also use range. Also, weather forecast, the meteorological department, they make use of range to determine the minimum temperature and the maximum temperature. Then you can look at the mean deviation. The mean deviation is obtained by calculating the absolute deviation of each observation from median or mean, and then averaging this deviation by taking the arithmetic mean. The formula for mean deviation is equals to summation of x minus x over n. This is x minus x bar. If the mean deviation is small, the distribution is highly compact or uniform. The relative measure corresponding to the average deviation, called the coefficient of mean deviation, is obtained by dividing average of mean by the measure of central tendency used. So what they say is that apart from calculating the mean deviation, we also calculate what we call the coefficient of mean deviation, which we get by dividing what you get here by the measure of central tendency used. Because you have said you can either use the mean or median. So by the measure of central tendency used, i.e. mean or The scores for 10 students were as follows. Get the summation of x is 618. Required. Determine the absolute mean deviation. So to get the mean deviation, first of all, get what? X bar. X bar is the mean. Sindio? Itakuwa ngapi? 618 divided by 10. Mean, it is the average. Okay. So for ungrouped data, like this one, to get the mean, you add this total, you divide by the number of items. These are 10 items. Okay? That is what I've done here. So you get what? 61.8. So get 61.8, 60, and this one minus this on the negative side. Put it to the side. Okay? So it is 1.8. Isn't it? This minus this. This minus 45, 16.8, 13.2, 8.2, this is 3.
8.
Oh, the next one?
Yeah.
3.2,
21.8,
21.8, 7.2, 2.2,
11.8, 18.2.
18.2. Then they give us a total of
104.4.
4.4. So therefore, our mean deviation is equals to, oh, this is the formula. So it is 104.4 over 10. Get what? 10.44. That is the mean deviation. Example 2. In this example, we have firms. Then we have amount of loan per firm. Yeah. So this is F, this is X. So from this data, calculate the mean deviation. First of all, you get what? The mean. Okay? And the mean here, it will be summation of Fx over summation of F. Okay? So what you need to do is to get a column here, you call it Fx. Are you together? So Fx, it will be 3 times 20,000 is how much? 60,000. Okay? 4 times 16, that is 240,000. Okay?
Yes.
You have 1 times 1 times 15, it's 15. 5 times 12,000, 60. 6 times 14,000, it's 84,000. If you add this, they will give you what? A summation of Fx, which is 459,000. Okay. Then, this one is not visible. So we are using the formula summation of Fx over summation of F. We have seen the summation of Fx here and F here. This is 459,000 divided by 19. You get 241, 24,157. Point. X So you get this minus this. You ignore the sign. So this is 41, 57.9. Then this one, the second one,
35,
842.1. The other one,
91, 57,
57.9. The other one,
121, 57, 29,
the last one,
101, 57,
0.9. That is that. Just leave it at that. Then we are told that to calculate the mean deviation. Mean deviation. Our mean deviation, you get it by summation of x minus x bar over summation of f. So x minus x bar summation yake
71,
71,
473,
473.7. Okay. We need another column here, which will be f, that is x minus x bar f. Okay. So x minus x bar times f, which is this times this. Okay? You get 12, 473.7. So this is 12, 473.7, the other 143, 368, 24, 21, 57, 9, 11, 60, 78, 5, last one, 69, 47, 24 total, 86, 736, 29. Then here our mean deviation is summation of f x minus x bar, that is this column, divided by summation of f. So it is 286, 736.9 divided by 18. Then the answer that you get, that will be our mean deviation, which is 15,091. 15,091.4 shillings. Have to indicate whether it is shillings, whether it is units, whether it is base or bins. Okay?